Okay, so we're going to review the normal distribution, and I'm going to talk through this page fairly quickly, and then we're going to get to the problems. So, really important theoretical idea in statistics. It can be used to describe many things: height, weight, IQ, SAT scores, etc. The normal distribution is a continuous distribution that you can have decimal answers, like your height can be 6 foot 0.0001, your weight can be 199.325. So you can have any type of fractional answer. Also, the normal curve can have any different mean and can be all sorts of spread out. Here we have the same mean shown, but the one with the dashed line has a smaller standard deviation, so it's not as spread out, but all of them have an area equal to 1. So the area under the dashed line is 1, the area under the solid line is 1, the area under the dotted line is 1. So the area will remain the same. They all go to negative infinity to positive infinity, all right? But the smaller the standard deviation, the closer things are to the mean. The larger the standard deviation, the more spread out they are. The normal curve has a very ugly looking equation that you don't need to know, just having it, showing it to you right there. I do want to point out, here's the mean, and then right here we have the standard deviation. All right, so we have the standard deviation occurring twice in the equation, the mean occurring once. There are an infinite number of normal curves because we have an infinite number of means. We also have an infinite number of standard deviations. However, we can all normal curves follow this general rule. Now, this is a rule of thumb. In other words, it's close, not perfectly right, but it's really close. 68% of the data is within plus or minus 1 standard deviation, 95% are plus or minus 2 standard deviations, and 99.7 is plus or minus 3 standard deviations. This is known as the empirical rule, all right? And you need to memorize that. That's one thing, please memorize. Looking at it on a graph, it might look something like this. We're centered at 0, and 68% of the data is within plus or minus 1 standard deviation, or this purple section. 95% of the data centered on the mean is plus or minus 2 standard deviations, and all the way out to -3 and +3, we have 99.7%. Now, please remember, this goes to positive infinity, and this goes to negative infinity. So there's a little bit more out there, but not much. There's not much in the tails, okay? Once you get beyond 3 standard deviations, there's not much there. All right, so because we have an infinite number of normal distributions, we like to use the Z formula to relate them all to one particular characteristic. Because please remember, they all follow the empirical rule. All of them follow the empirical rule, so we can scale them down by z-scores. And a z-score just tells you how many standard deviations something is from the mean, all right? The z-score just tells you how many standard deviations are from the mean. And by the way, I'm going through these really quickly. You should read these on your own, but I'm kind of hitting the high points. So we know the 68% is centered on 0. Well, that means my z-score is 0. 1 standard deviation above, this is 2 standard deviations above, this is 3 standard deviations. Negative z-score, 1 standard deviation below, 2 standard deviations below, 3 standard deviations below. This right here, I just can't emphasize enough. All z-scores. If I give you a z-score, it's like, oh, I know what the mean is. The mean is 0. If I tell you it's a z-score, or if I'm looking for a z-score, the standard deviation is 1, and you're going to need this at the end of the week. So please don't forget this. Mean of 0, standard deviation of 1 is true for all z-scores. Okay? So let's do some calculations. And once again, can't emphasize enough. Always 0, always 1. So what's the probability that z is less than negative 0.84? You always need to begin by drawing a picture. So here we go. I'm going to draw a little picture right here. Since it's a z-score, guess what? My mean is 0 and my standard deviation is 1. Well, this goes to positive infinity and this goes to negative infinity. Well, I know that this is a negative value, so it must be below 0. I don't know where it is below 0, but it's somewhere below 0. So this is negative 0.84. And notice I have a less than symbol, so I'm shading to the left. Well, anytime we're working with a normal problem, they're going to tell you it's normal. So this is a normal. We will never use a PDF. It'll always be a CDF. So normal CDF. Let's just see what the calculator asks for. All right. So second vars, normal CDF. Oh, it asks for a lower, an upper, a mean, and a standard deviation. Okay, well, what's my lower? Well, it goes to negative infinity. So my lower is negative infinity. My upper part of my shaded is negative 0.84. So lower, upper, and then we have a mean of 0 because it's a z-score and a standard deviation of 1. That right there is what you need to show in order to receive full credit. So negative 99999, loaded up some 9s. My upper was negative, negative 0.84. My mean is 0, standard deviation 1 because we're working with a z-score. Press enter, and I get 0.2004. Please always truncate. The next one. All right, so we have a positive 0.57. We always need to draw our picture. We're going from negative infinity to positive infinity. 0.57 is above 0. That's up here. So this is above 0, and it has a greater than. Because it's greater, not because it's above, but because it's a greater than symbol, I need to shade up. Well, we're working with a normal because it's a z-score, so normal CDF. My lower part, well, the lower part of my shading is 0.57. The upper part of my shading is positive infinity. It's a z-score, and all z-scores have a mean equal to 0 and a standard deviation equal to 1. So my mean is 0 and my standard deviation is 1. So here we go. Second vars, normal, CDF. The lower part of my shading was 0.57. The upper part of my shading was infinity. So mean is 0, standard deviation of 1. All right. And I end up getting 0.2843. On the last one, okay, again, we're working with the z, so we know my mean is 0, we know my standard deviation is 1, and we know it's a z, so that means it's centered at 0, because that's the mean. And I have a negative value, so that means it's below 0, so this is negative 0.25, and then I have a positive value, which is 1.3, which is above 0, and they want the value area in between. So they're looking for this area right here. So once again, norm CDF, lower is negative 0.25, upper is 1.3, mean is 0, standard deviation is 1. So let's try that out. Second vars, normal CDF, negative 0.25, 1.3, because that's the upper part of my shaded. Mean is 0, standard deviation of 1. And I end up getting 0.5019. All right. Once again, the lower part of my shading was negative 0.25. The upper part of my shading was 1.3. Mean and standard deviation are always going to be 0 and 1 if we're working with z-scores. Okay, so that's working with z-scores, but what happens if we're working with something that's not a z-score, but it's still normal? So the normal, the November 20th, 2018 CDC National Health Statistics reports that the average weight of women in the U.S. over the age of 20 is normally distributed with a mean of 77.4 and a standard deviation of 0.8. So we have a mean equal to 77.4, a standard deviation equal to 0.8. And by the way, this really is real data. This is not made up. And they tell us it's normally distributed. All right, because it's normally distributed, we know that we can use the normal distribution for this problem. All right, so my probability statement is going to be this. What is the probability a randomly selected woman weighs more than 79.2? So what's the probability that X is greater than 79.2? Well, I'm going to go ahead and draw my normal curve out. And we said the mean was at 77.4. And 79 is definitely above 77, so I'm going to make a 79 here. 79.2. Please remember this goes to negative infinity and this goes to positive infinity. And I have a greater than, so that means I'm shading up. Well, they told me it's normal. Norm. We always use the CDF when we're working with a normal in this class. The lower part of my shading is 79.2. The upper part of my shading is positive infinity. The mean, now in this case, our mean is 77.4. And our standard deviation is 0.8. So second vars, normal, CDF, lower part 79.2, upper part infinity, 77.4, standard deviation 0.8. So this is 0.0122. All right. And notice this right here, you need to show all that work. You need to have the picture, the probability statement, what you're putting in the calculator, and then your answer. The next one, what is the probability a randomly selected woman weighs less than 76 kilograms? So the probability that the woman weighs less than 76. So X is less than 76. So we go back to our picture. We know it's centered at 77.4. And 76 is below that. So this is going to be 76 here. This is positive infinity. This is negative infinity. And since it's a less than, I'm shading to the left. So that's what I'm looking for. This needs to be a norm CDF. The lower part of my shading goes to negative infinity. The upper part of my shading goes to 76. My mean is 77.4. And my standard deviation happens to be 0.8. And that was given to us in the problem. So right here is all the work that I need to show. Second vars, normal, CDF. Lower part of my shading, negative infinity. Upper part of my shading was 76. My mean was 77.4 and my standard deviation was 0.8. And I end up getting 0.05019. 0.400. Please always truncate. Go to 4 decimal places and truncate. Next one. What's the probability a randomly selected woman weighs between 76.5 and 78 kilograms? All right. So here we have two values. So my probability statement is going to look like this. 76.5 is less than X is less than 78. Negative infinity, positive infinity, 77.4. So right here, this is 76.5. This right here is 78. So I'm looking for this area between 76.5 and 78, and that's what my probability statement says. So it says the same thing, okay? So once again, norm, CDF. The lowest part of my shading was 76.5. The highest part of my shading is 78. My mean is 77.4, and my standard deviation is 0.8. All right. So plugging that into the calculator, second vars, normal, CDF, the lower part of my shading, 76.5 right there. The upper part of my shading, 78 right there. Mean is 77.4, standard deviation 0.8. And I end up getting 0.6430. Once again, 4 decimal places and cut it off. Do not round. Right? It just makes it easier for all of us to have the same answer. The next thing, what is the probability that a randomly selected woman weighs between 76 and 77 kilograms? All right, so we have two values. So our probability statement is going to look like this. The probability of 76 is less than X is less than 77. So 76 and 77 are both below. So let's just say this is 77, this is 76, and I want the area in between. So that's what I'm looking for. Don't forget, this goes to negative infinity, and this goes to positive infinity. So they've told us it's normal. Lower bound 76. Lower part of the shading is 76. The upper part of the shading happens to be 77. Our mean is 77.4, and our standard deviation is 0.8. Second vars, normal, CDF, 76, 77, 77.4, 0.8, and we end up getting 0.2684. 0.2684. No rounding, just 4 decimal places and mark it off. Okay? All right, so that's our review and on normal distribution. Please make sure you're really comfortable with it because we're going to be using it a lot.